I get the great privilege to introduce the mighty Andrew Bell, rock star coder and developer of the Cinder library. And he's kind of owned the creative coding world, and he's going to talk to us about how you do that. So over to you, Andrew.
Thanks, man. So I'm going to start a little off script and first just say what a privilege it's been hanging out with y'all for the past couple of days. I don't use JUCE particularly, which the reasons will become clear shortly. But it's really been an honor just seeing the quality of work that's come out of this community. I've just really been amazed these past 2 days. And I've also gotten to know Jules over the past couple of years. And I think his technical ability is very obvious. You don't really need me to talk about that. But I've gotten to have some conversations with him just sort of as one framework author to another. And it's just very obvious to me sort of the passion that he brings, not just to the tool itself, but really to this whole community of people. So in my opinion, y'all are lucky to have him and his team. And I'm excited to see just the Rolly relationship as well. I think will be great for everybody in this room. So with that, let me get started. I'll talk about creative coding with C++. And I'm using that term creative coding in kind of a technical sense. I'll give it a definition shortly. And so in addition to that, we'll talk about some work that hopefully is inspiring to people in this room. We'll talk about some stuff that's a little different than probably what a number of you work on. But I think you'll find it relevant even just to your creative process. That's at least my hope. And then we'll talk a little bit about how to experiment with this style of coding, specifically with Cinder. So if I begin with this definition, creative coding is kind of like a wanky term. It's not one I would have invented. I certainly didn't invent it. But it has kind of stuck. And the way that I would define it now that we're saddled with it is that it's programming with aesthetic intent. But probably a more direct route for giving it a definition would be just a short clip. So I'm going to run about a minute-long reel. This is all work that's done with Cinder, but hopefully it will serve as kind of a visual definition of this term. So I'll fire that up. So we'll use that as maybe a working definition of creative coding. It's these kinds of interactive projects, big screens, touch screens, that sort of stuff, music visualizations. And part of why I'm here is sort of rooted in this quote from Bjarne. Nobody knows what most C++ programmers do, right? This is a huge language. There's so many different problem domains represented by C++, but there's a lot of value in us sort of being aware of each other. And obviously, the work that I'll show today is not wildly different from the kinds of work that you do. Realistically, much of what we've seen today would fall under this sort of crappy umbrella term of creative coding. So creative coding has really been legitimized lately. A number of schools, these are American schools, but we've heard from some here in the UK. There's a number of schools around the world that are teaching sort of creative coding formally. And there's several tools that have emerged as some of the most popular. We've heard reference today to processing, which is essentially a wrapper around Java, although Java, of course, has fallen out of favor. If anyone from Google is listening. And processing even itself has really shifted over to JavaScript. And then JavaScript as a language has become a pretty popular tool for this sort of work. We saw from Mick, from Maximilian, the travesty of running Emscripten on your C++ code, perfectly good C++ code getting put on the web. And particularly 3JS has done a lot for sort of creative code in a JavaScript context. And then a number of proprietary tools, Flash and Unity. One of these is basically dead, but for commercial tools, those show up a good bit. And so it's worth thinking about in light of all these other tools and specifically other languages, is C++ really a good choice for creative coding? And in some ways it's not. And in other ways it is. I'll sort of try to defend that statement. The reasons it's not, for me, the primary one is really build times, right? Creative code is like any other kind of design process. It's about iteration. In the music world, you iterate a lot as well, and that's certainly true for visual design, interaction design. C++ sucks for building. And then the other thing, there's this kind of rule of thumb that would say that your app spends 90% of its time in 10% of the code, but you still got to write that other 90%. And that can be very painful with C++, right? If you're not super competent with the STL yet, or with any number of problems unique to C++, then writing that large part of your app is very painful. The flip side of that is, of course, when you need that 10% to be crazy fast, there's really only one choice, and that is C++. And so for everybody in this room, you're thinking a lot about hard real-time. In the creative coding world, we might call it a kind of a soft real-time, like nobody's pacemaker dies if we miss a frame. And we're trying to hit something more like 60 hertz than 48,000 hertz. But we're still pretty interested in high frame rates. That can be the difference between what's an appealing interactive experience and the opposite. And then creative coders are always looking for non-obvious uses of libraries and hardware, right? So there's all kinds of really amazing libraries for lots of tasks where the author might not quite have intended it to be used in the way that a creative coder who sort of didn't get the memo about what it was supposed to be used for does something non-obvious with it. Same with hardware, and by hardware I think about things like the Kinect or depth cameras of different varieties, VR, those sorts of things. We're really interested in accessing that kind of stuff, and C++ is the only real choice for that as well. So with that, let's just take a look at some work. And again, my motivation in showing you this work is hopefully just to trigger some thoughts in your own creative process, maybe inspire some of you to experiment with this style of coding as well. All of these projects are done with Cinder. A lot of them are professional projects, but hopefully still very relevant to your interests. So this is a project from a company called Murata, and this was created for IBM. This was installed outside of the Lincoln Center, and this is a 110-foot display that is visualizing in real time all kinds of data that's being pulled in about New York City. So you have things like the traffic patterns or the air quality, all of that kind of stuff is being rendered live with a Cinder app on this massive display in New York City. A company called Collision did a couple of projects for Audi. So that is sort of a people tracking software, overhead depth cameras. And then they did a really novel thing here with these LED panels. So these are usually used for digital signage, but Collision made sort of a digital floorage, I guess. And so this very novel display that's beneath your feet, you can't cast shadows on it. Pretty nice result. And this is another they did also for Audi. So these are kind of like, I'd say, low resolution holographic displays. They're matrices of LEDs that are just these really artful kind of slightly abstract displays that are there on the side of the road. A company called Hush built this for Nike. So these are a pair of human-powered treadmills, and they're able to determine how quickly you're running. And using that, they created a sort of a head-to-head race where different visitors could run against one another, and then it would, declare a winner, and the loser has to work in a Nike sweatshop. I'm speculating. I don't know that for sure. That might not be true. I like this. This is for Charity Water. So this shows when you give a nonprofit access to the same kinds of tools that big brands usually exclusively have. So Charity Water is a really huge clean water charity. They built a number of interactive installations like this, which shows you how much water you've pumped. There's a number of touch screens that are just sort of reinforcing their message. And then you'll see shortly, that's an RFID bracelet that was people's ticket into the event, and then they did a live auction sort of bidding system where as people would pledge money, they'd see their name in real time go up on this huge display. And they're able to turn into kind of a shared experience raising this. I think they were raising money for Rwanda that year. But you could see the total sort of tick up, and then there was a big party when they hit the goal. A company called Field is actually an English company. This is a piece they did for La Gaîté, and what you see here is a room full of essentially generative creatures. So little algorithms created these kind of biological entities, and then they're all listening to the music and dancing in the ways that sort of their unique skeleton enables. So a nice sort of use of audio analysis in combination with some other things. A company called Breakfast built this. So they took those flipping dot displays that you see. I assume you'll have them here. We have them in the US. And Breakfast rewired the electronics so that it could run not at 1 frame per second, but 30 frames a second, and then used a special Panasonic depth camera that works outdoors to create this interactive display. This was in promotion of a TV show called Perception. A company called The Mill is a quite sizable English visual effects company. In their New York office, they wanted to do something to sort of recognize their 20-year portfolio. So they created this touchscreen with Cinder that allows you to pull up basically every job they've ever worked on, and then you can interact with it in different sort of interesting ways. So that lens is a real-time view into the before and after of the visual effects process that's all running sort of interactively. A company called Fathom built this for General Electric. So the annual reports for GE go back many, many years, the 1800s, and they're actually really beautiful documents that are very indicative of the kind of visual design of their respective eras. And so Fathom built this iPad app that allows you to sort of interact with that full history. And Creative Code absolutely extends to these style of tablet apps, mobile apps, that sort of thing as well. A company called MID built this. This is for the Pablo Picasso Museum in Barcelona. They did some novel sort of hardware engineering to create a pretty unique kind of physical interface, and then, which you see there. And then there's a number of touch screens and interactive displays throughout the museum. And as you can imagine, a lot of Cinder's users are the show must go on. I'm sorry you died. Are coming out of the museum space. Obviously, museums are very interested in this sort of new generation of exhibit. Stefan Sagmeister, pretty well-known graphic designer, built this for a museum in Philadelphia. So he took some pretty sophisticated sort of psychology research software that does facial feature detection, and in particular can depict or sort of analyze smiles. So your physical smile is what triggers the projection mapping onto these sugar cubes. So until you smile, it won't do anything, and when you do, it sort of lights up. Good example of what I was talking about, creative coders using external libraries in ways that God never intended. A company called The Locals is an Australian company that built this in Sydney. This, of course, is indicative of another wide class of Cinder users, which is retail. So they activated the exterior of this Nike store for touch. And some of what is unique about that is it allows the store to continue to function as a store even when the lights are off and the door is locked. You'll see the sort of physical lighting in the store can highlight products as you select them from the touchscreen. Pretty novel execution. Red Paper Heart's a great boutique that works pretty exclusively in Cinder. They also built a sort of bicycle-based head-to-head race. This is a nice interactive piece that they did for Sonos. And then they covered the surface of a swimming pool and ping pong balls, and then projection mapped audio reactive visuals onto the surface of this pool. It looks like a pretty good party. And I feel like as a metaphor for C++ as a language, is a co-ed pool party is almost indistinguishable from C++ coding. The Media Lab at MIT has been using Cinder for some of their human-computer interface research. So this, you see these iPads are sort of virtual windows into this shared space, and then they have some quite fancy hand tracking technology that's incorporated with that allows people to interact with these interfaces very intuitively. This is a nice example of some of the more pure art that's being done with Cinder. This is a dance performance where some projections serve almost as like an additional actor. So these displays are responding in real time to the motion of the dancers. Wyden's a very famous ad agency. They've done quite a number of Cinder projects. This is one they did for Coca-Cola. So the idea behind this was installed at Venice Beach, and basically you're forced to ride this elaborate bicycle to the number of calories that are in a Coca-Cola. So I believe that number may be 140. So once you have burned off 140 calories, then you are rewarded with free Coca-Cola. Oh, so there's somebody who did it. And then they also built this, the film Box Trolls, if anybody saw that. These displays were installed in a bunch of movie theaters. They're interactive displays, so these characters will respond to and mimic your motion as you move around in front of them. So with that, let me give a little bit of background on Cinder. We'll be brief with this, but Cinder is an open source C++ library for creative coding. It's really tuned for professional users, although it gets taught in schools and that sort of thing as well. Some of its properties, it's very sort of modern C++, so we're super down with 11 and 14 as numbers. It's BSD licensed, so you can do whatever you want. It supports OS 10 and Windows, iOS, Linux. Linux and Android are not quite as mature, but are very here. And in particular, a Google employee named Hai Nguyen has done a really heroic job of getting Cinder running on Android, and he has suffered the indignity of writing Java code so that you don't have to. It has a pretty global user community. And last time I checked, there was over 75 names in the commit history. So we have pretty active participation from our users. Even though the license is BSD, people still choose to contribute a lot of code. Features that you probably would expect, we use GLM for math, which has become sort of the standard for graphics programming math primitives. A lot of specific OpenGL support, but we also do Cairo, and then DirectX, and in particular a flavor of DirectX through Google's Angle project, which is really excellent. That sort of abstracts DX in favor of ES2 and ES3. We can do video, playback, record, that sort of stuff. There's a room full of audio people, so like I'm actually not an audio guy, and I didn't write any of that code, but I asked the guy who did, how should I describe it in a sentence? He said, it's architected very similar to the web audio architecture, so it's a graph-based API, and we took a lot of inspiration from web audio architecturally. By God's grace, it's not JavaScript. User interface in a kind of a mouse keyboard multi-touch sense, all of these are abstracted. We've got super boring things like networking, XML, JSON, all the kind of stuff you just sort of need for this kind of work. If anybody's familiar with ASIO, we use that for a networking library, a pretty sophisticated multi-threaded sort of abstraction that is likely going to be in I think TR2, but it's available now if you want to use it. A lot of different kinds of companies use Cinder. So famous agencies like Ogilvy and Firstborn. Pentagram is originally an English design firm that most people say is the best in the world. We're also seeing, of course, tech companies. So Microsoft is a good example where they actually put full-time employees on just porting Cinder to Windows RT and then sent me a big fat pull request. That was sort of the fruit of that labor. Intel has been shipping native Cinder support for some of their hardware products, like their depth camera, in addition to using it for their own R&D. Google has used it for user interface R&D in particular, so an early version was ported to Google Glass before anybody knew what Glass was. They were prototyping on the device. Apple does the same thing, but I didn't put their logo because I assumed they would sue me for even mentioning that they exist as a company. I apologize, Apple. None of that ever happened. Big VFX companies, Industrial Light and Magic, others have used Cinder. It won a friggin' ad award. This is like strange to me, but this is generally considered the biggest award in the ad industry. So we won a Grand Prix at Cannes. I can say with confidence we're the only pile of C++ code to ever win a Cannes Lion. It is also part of the Smithsonian's holdings now. So this app called Planetary was a music exploration app that the Smithsonian acquired as sort of their first code-driven design holding. So the Cooper Hewitt holds the rights to Planetary as sort of an art object, and I think in some dusty hall of the Smithsonian is like a dot matrix printout of the Cinder source code, or at least I like to believe that's the case. Brief history of Cinder. It originated with me presiding over the Richardson High School Computer Club in Dallas, Texas. And weirdly, even some of the ideas and code of Cinder dates back to this far. This obviously being an organization you would join to meet women. I worked in the visual effects industry for a long time, so there's a lot in common between technical directing, visual effects, and what we would kind of call creative coding. So a lot of Cinder is rooted in this era of my career before it was open source. I co-wrote the music visualizer that's in iTunes, and so this was actually the first commercial Cinder project. If anyone is a hallucinogenic drug user, then you may be familiar with this. We did an augmented reality issue of Esquire magazine. It was the first magazine to do this sort of thing. So you could hold up the physical magazine to your webcam, and then we would map onto the cover sort of additional content based on what page you were holding up. Sort of early Cinder app as well. In fact, that was the last closed source Cinder app. And then we open sourced it in 2010. Not long after, I was working at a company called Barbarian Group. That's an interactive ad agency. And when we open sourced it, I was around the same time that I was going to work back in the visual effects industry for a while. For reasons I won't say from the stage, I decided I did not want to continue that job. And so I called Barbarian and said, you know, hey, what would you pay me to never make you any money and never work on your client work and just work on Cinder and just run this open source project that had started to get pretty big? And strangely, they said, okay. And so I still hold what we call a fellowship at Barbarian. That's just them sort of sponsoring work on Cinder. They don't control it or own it, but they do give me a desk to sit at and a MacBook Pro that I brought here to London. This is kind of just a boilerplate. This is kind of the core of a Cinder app. So we just derive from a Cinder app class. And then we can override virtual method. There's more sophisticated signal and slot mechanisms for very fancy event stuff, but just for the basics, we just override some virtual methods. And then there's this sort of macro that actually instantiates your app, and we like go sacrifice a chicken or whatever is necessary on your platform to actually spin up a real app. In some rooms, it might be a question, well, why would we even use a framework? Honestly, if you're in this room, you probably get frameworks. That is kind of a given. So there's some basic reasons, but this one I feel like is a really key one, right? So to be able to interop with your fellow humans is a big deal. There's a lot of companies that exclusively use Cinder. Their whole business model is make Cinder apps for money. For them, this is about hiring, right? So they can hire a certain caliber of coder, and they know that they come in with a set of knowledge. If you know Cinder, I promise you I can get you work. I got an email this morning. I get a few a week that's like, hey, we need a Cinder developer for this. It's a good way to make money. So for them, that's why they've standardized on Cinder. But if you're just somebody who's interested in this stuff, a lot of what that's about is kind of summed up in Cinder blocks. These are like, I think you all have JUCE modules. Cinder block is just sort of a collection of headers and source and binaries that are necessary to expose a certain feature. A lot of them come with project templates that just sort of get you started with whatever it is. So good examples like the Connect, computer vision through OpenCV, various physics libraries, VR, HMDs. If you own a Canon DSLR, then there's a nice SDK that you can talk to and make a photo booth. We'll use the Magic Leap as not Magic Leap, Leap Motion and there's a Cinder block for this. Leap actually did a lot of their launch demos using Cinder, and then they open sourced them as well. But this is kind of like a desktop form factor Connect, so it's able to track your hands and sort of do basic gesture recognition, that sort of stuff. So if we're going to use this Cinder block, we just clone it off of GitHub and blast it into the blocks directory of the Cinder distribution. A lot of Cinder blocks will ship with examples that you should just be able to double-click the Xcode project or the VC project, and it'll just work. So this is one that's just doing basic hand tracking. That's kind of the core of the Leap motion. We have a tool called Tinderbox that's kind of like not as fancy an intro juicer, and it allows you to pick your platforms. I've selected in this example the Leap Motion project template. That's just part of the Cinder block. That's just to help me kind of jumpstart experimenting with it. And then I could choose other Cinder blocks if I chose to. So this is what we're going to aim for. This is just, you know, a hand, and we've mapped a cube to each of the fingers and then sort of drawn a vector of orientation. So walking through a little bit of this code, you know, we've got our basic app. We've included the Cinder blocks header. We've got a setup and draw method, which is inherited from the processing sort of popularized this way of working. And then we've got a shared pointer to the Leap device itself, and then a current frame of data that's come in from the Leap, and then a 3D camera. Camera persp is just sort of our OpenGL style camera. So we sort of give the parameters for the camera, how wide and tall and what the field of view would be, tell it where to look from in 3 space and where to look at in 3 space, fire up the Leap Motion device, and then we throw a lambda at the device and say, hey, this is a callback for every frame of data that comes in. Please, you know, we're just going to set our local variable. That's a copy of the Leap's latest data. And then the draw method, we're just going to clear out the screen for OpenGL, set our OpenGL matrices to reflect that 3D camera. We're going to iterate the hands, which will just be 0 to 2 hands, unless you, maybe if you grew up next to Chernobyl, that could be different. And then each hand will have probably 1 to 5 pointables, Chernobyl accepted again. And so we just look at each pointable and we say, hey, which way are you sort of oriented? How long are you? Where's your position in 3 space? Do a little bit of vector math to sort of get a line that matches that. And then we're going to draw a cube. That's just a convenience method that's built into Cinder at the point of that sort of finger. And then we're going to set the color to gray and draw a line down the length of it. And when we put all that together, you know, picture my hand doing something kind of like this in a hotel room. And that is that. So pretty good result for very little code. And actually, we didn't even write any of that code. Tinderbox just pre-populated that code because we picked the Leap Motion template. Box2D is a good example of something. So this was made famous by the game Angry Birds. This is the physics engine that it took advantage of. If we use its sort of built-in template, this is what we're going to shoot for. It's just a little app where everywhere we click, a box falls and does kind of realistic physicsy things. So we're going to derive from the app class. We got some mouse interaction this time. We make a unique pointer to the physics world, and then lazily I've just made a pair that pairs a color with the Box2D shape that's associated with it. And we're just going to make a vector of those pairs. In the setup, we sort of tell Box2D, oh, there's this thing called gravity. It's negative 9.8 meters per second. Here's this thing called the ground. Now, Box2D doesn't do any rendering, but it has these notions of sort of bodies and that sort of thing. So we sort of give it the ground, and that's really the setup. And then in mouse down, we're just going to pull out from the mouse event we got past. I think this is fairly similar to JUCE. Set a position for the box and give it some physical properties. What's its density? What's its coefficient of friction? And then last step, we're going to generate a random HSV color and throw onto that vector the pairing of the color and the box 2D shape. Last bit here, we just advance the physics simulation from our update method, and then when we draw, we're going to clear out the screen, iterate that vector of pairs, and we'll save off the matrices as sort of standard OpenGL dance moves, translate and rotate based on the properties of the box 2D stuff, and then finally we'll call a draw solid rect in the color that's for this box, and when we put it all together, we get this. Physics is always sort of oddly satisfying to watch, I think. So it's not Angry Birds, it's also not wildly different from Angry Birds, but you don't have millions of dollars and some guys do. Not the author of Box 2D, incidentally. That's the trap of the BSD license. So OpenCV, pretty famous computer vision library. Face detection is one of the things that's sort of best known for. Same kind of move, we'll pull that up. In our setup method, we're just going to turn on OpenGL alpha blending. We load what's called a HAR cascade, which is just a kind of computer vision-y idea for object detection. This has been trained with a big data set. You know, there's this kind of, it's not quite machine learning, but in that realm. So we load that in. Get asset path is just a sort of Cinder-y idea for loading, external files. Spark up the webcam by calling capture create, and then we tell it to start. And then the update method, we're going to pull in from that capture what's the latest frame of color imagery. We turn it into an OpenGL texture, right? Because we're a GL app, that's the only way we can efficiently draw pixels. And then we're going to use OpenCV's method for turning this into a grayscale image, because face detection only works on grayscale. We'll use CV's equalize histogram, which just essentially increases the contrast, which makes face detecting happier. We'll clear out our vector of faces, and then this is the magic routine we call on that cascade that just says, hey, I gave you a grayscale image, please find me all the faces in it. What comes back is that vector of OpenCV rects, and we just iterate that and turn that into a vector of Cinder rects. And this from OpenCV method here is a good example of sort of Cinder's philosophy when we wrap third-party libraries. We generally try to create pretty thin shims between Cinder's types and that library's types. That's sort of a philosophical choice, which is saying, hey, you aren't meant to learn Cinder OpenCV, you're meant to learn OpenCV and all the power that's within. So we're not gonna like trick you into learning some wrapper around OpenCV. It's just like use OpenCV as conveniently as possible. So when we draw, we draw the camera texture if we have one. Webcam usually takes a few frames to kind of wake up, so that could be null initially. We draw the camera texture itself, and then we set the color to kind of transparent yellow, and then draw solid rect sort of where the faces are. And when we do that, if you're me, you'll see this. And if you're Bjarne, you see that. It's a good-looking man. Fluid simulation. This is a good example of a Cinder block. This was actually written by the same Hai Nguyen of Google, and he's done a pretty hardcore implementation of Navier-Stokes, which is just a 2D differential equation system that mimics shallow fluids. So what we'd like to hit is this result. That's sort of a black and white simple fluid. And we'll use his project template in Tinderbox. Some regular business, we'll make an instance of his fluid 2D class. We set some physical properties on it, how quickly it dissipates, which makes it feel more like liquid or more like smoke, that sort of stuff. And then from the mouse handler, we're just going to record into a member variable where was the mouse the last time. And then we normalize that mouse down into, or drag rather, into the coordinate system of the fluid. And then if the left mouse button is down, then we splat, or kind of just spray, if that's a better word than splat, I don't know, spray some velocity and spray some density into the fluid at that spot. here, we'll advance the physics much like we did in Box 2D, clear out the screen for draw. We use Cinder's channel class, which just represents sort of like a grayscale image. The 32F, of course, denotes that it is a floating point image. So for people that are interested in this sort of thing, Cinder has a full high dynamic range pipeline, both on the software side and the hardware side, if that is important to you. If this is the first time we've been in Draw, then create a texture. We use stood shared pointer throughout Cinder. Create is a static method on most of our classes that's just meant to kind of jumpstart shared pointers. And then we're going to update that. If we have been here before, updating is more efficient for a geotexture than allocate a new one. Draw the texture, scale it to the boundaries of the screen, put it all together, and get a pretty realistic fluid sim. It actually runs comparably well on a mobile phone or that sort of thing. Hi is used to work in visual effects and is not screwing around with fluids. So if you're a fluids guy, which we're all 2/3 water, so you know. So I'm going to close with two kind of competing ends of the spectrum here. I'm going to show you all a project. This is the one example, long story, of me doing client work at Barbarian Group. So I ran the software team for this clip that I'll run for you. This is a project called Center Stage that we did for Samsung. So I show that in part because it ruined my life for 9 months. But also, it's a good example of this one end of the spectrum, which is there are many, many specialized professionals working on a project like that. Same VFX company that did the Transformers 4 effects did those CG sequences, a lot of very custom graphics work. But it also shows sort of a lot of what Cinder is meant for. So that collective display is 7,008 by 3840 pixels. It's spread across 9 physical displays. It's over 12 times high def. So traditional 1080p high def is literally less than a 1/12 of that. It's basically one of these monitors. And that's all driven by a single machine, which was one of the kind of business requirements, is this is meant to be deployed to up to 2,000 installations around the world. And consequently, we need to minimize points of failure. So when you have to write very tuned OpenGL interactive kind of stuff, this runs at 60 hertz pretty consistently. Cinder really shines, and that's a lot of why people would endure the pain of C++ at all, is to be able to do something like this. And then the last bit of example I'll show you before I close is the work of Robert Hodgin. And some of why I wanted to close with this is Robert's on the other end of the spectrum. He works alone for a number of social reasons, and he's obviously talented, but he truly represents not only what somebody can do alone with Cinder, but he has no formal training in computer science whatsoever. He has a degree in sculpture. He has not even written C++ code for that many years. I want to say probably 6 or 7 in total. But he shows sort of why creative coding can be interesting. This first of two examples of his, this is a project he did for a museum in New Zealand. It's meant to be sort of like a walk-in VR experience, and it's depicting a sort of oceanographic phenomenon called the bait ball, where it's sort of this crazy interaction of all these different predator-prey fish that creates something we'll see shortly. So he just starts modeling this phenomenon with sort of a particle system. He's thinking about each fish as a particle and sort of how do these fish interact. So he begins just defining a sphere of influence. You know, what's the radius that one fish is disinterested in another fish? Within that radius, there's a zone of repulsion that's saying, yo, you're getting too close, get off my fish nuts, and it does that. The other end of the spectrum, if you're like disinterested in me, I'm strangely attracted to you, much like a teenage girl, perhaps. So this other radius of like, ooh, what's that fish about? And then in the middle, we have a zone of alignment, right? So this is saying, I don't necessarily try to get near you, but I do want to match your velocity. I do want to match your orientation. These rules are actually first defined by Craig Reynolds. Computer graphics has academic literature like music does, or audio. And so if you're interested in this stuff, I really recommend this paper. It's a 1987 SIGGRAPH paper. The guy who wrote it around the simulation he did for that first Batman movie where all the bats are sort of flying around. That was where this sort of algorithm came from. So if you put all these rules together, as Robert did, you get this result. He's also got some predator-prey rules in there, but that first stuff is basically the heart of it. So here, obviously, these are just straightforward geometric shapes. But when he puts fish models, and actually just to speak, I mean, Robert knows some 3D modeling, but he just bought this fish off Turbo Squid, which is just like a site for sort of like not just fish parts, but all manner of 3D objects. And you know, so it didn't require him being like an expert in Cinema 4D or Maya or something like that. And then he put some sort of traditional computer graphics models for lighting. This one is called BlendFong for those interested in such things. And when you put all those things together and you orient the model in accordance with the velocity of that particle, and a few subtle rules, but nothing too crazy, you end up with something quite convincing, particularly when you're in a sort of VR environment. I like this clip too because it shows those laser beams coming out of the sharks' heads. And those, of course, are depicting kind of a reverse relationship. What prey is being influenced by that specific predator? So kind of a nice bit of data visualization, so to speak. And then the last piece with his, and I'm going to close with this. Again, I just want to show this as something that sort of one person can do. The core of this clip is Robert taking freely available textures from NASA, gluing them together with some math and some Cinder, and this all runs in real time. And in fact, this EarthSim runs at comparable frame rates even on an iPhone. Picture the Earth if there were not a projector issue here. So hopefully that and some other clips might inspire, you know, your own experimentation. I mean, I feel like there's a lot of talent in this room that's very relevant to the creative coding world, and we're kind of underrepresented with audio. A lot of creative coding is very visually focused, but there's some really amazing stuff that I'm quite sure people in this room would be able to put into the world. So with that, thanks for y'all's time.
Fantastic, inspiring stuff. Loved it. Thank you very much, Andrew. It's just gone 6. We're going to take a 5-minute break, and then we'll do our panel session. We could probably spend maybe a minute for a couple of quick questions for Andrew, if anyone's got any burning questions they want to ask.
Is that a Cinder pun? That's right. Yeah.
Anybody?
It's really a question for you both, which is, how does Cinder compare with JUCE?
Oh, should we just fight? Or?
Yeah. All right. I could cite a weakness of Cinder. I mean, obviously, JUCE is very famous for audio. That kind of goes without saying. But one thing Cinder is not useful for is what a lot of this conference has been about, which is like native feeling GUIs, that sort of thing. It's really not good at that. So we give you an OpenGL context. People build GUIs, but they're usually super custom. They're very particular to that installation or whatever, and you're not going to be like, whoa, is this a macOS app? Surprise, it's a Cinder app. You know, that would be one at least key difference, I think.
How much would you say it simplifies the process of getting into GL for someone who's not an OpenGL user? I mean, as a framework that wraps up that kind of functionality,
Sure.
How easy is it to get into for someone new to that area?
In my experience, fairly straightforward. We have the same philosophy as Perl. Easy things are easy, hard things are possible. And a lot of GL just gets onerously tedious. It's just like, oh, you want to make a frame buffer? Well, hope you've got an hour, you know. And with Cinder, you just you instantiate the FBO class and say, I want it this wide and this tall. So we've worked pretty hard to sort of, if you have an OpenGL book open, like the Super Bible or something like that, it's straightforward to understand what the corollary is in Cinder. Obviously, we introduced some level of abstraction intentionally. There's some subtleties to do with performance that we could talk about maybe offline that are things that would be fairly hard to get right on your own, that just do with like a software caching layer that you can remain ignorant of, but we're giving you some sort of perf for free. So it's fairly close. You're not going to feel hoodwinked, like I learned Cinder GL and now I don't really know real GL. But mercifully, you don't really have to do real GL either.
Let's have one more.
So you've been recorded now saying some project ruined 9 months of your life or 8 months or something like that. What do you mean by that? And do you have any tips to not get that?
Your life? Yeah. I mean, that was just a really intense project with a lot of eyes. I mean, that project had daily status reports to the president of Samsung Electronics. This was like a very interesting to Samsung project for straightforward reasons, right? Retail is really sort of under attack from the internet. So a lot of the mandate around this was build something that justifies a trip into Best Buy, or like Best Buy in England, whatever that may be. It's probably got an extra U in it. Best buoy. But I would say a lot of the stress around that project was just to do with how important it was to Samsung and how many eyeballs were on every single decision. And a lot of Cinder, if it's good at all, it's good because the people that develop it are in the throes of production. And that's one, I feel like I'm kind of always the bridesmaid, never the bride these days with Cinder, and in many others in my life. In that I'm not, it wasn't until I got back into it with this project and you sort of are like, oh man, why didn't anyone tell me this sucked? I'll like fix that right now, you know? So there's that kind of interplay of like working on the tool and working with the tool.
Okay, I think now we're going to take a few minutes break. You can get a coffee or maybe a beer because it's that time of the evening. And then we're going to finish off with a little QA session if anyone's still around. But before that, final big hand for Andrew. Thank you very much.